Good afternoon all the students. I am Dr. Prakash Bhadane. I am going to deliver lecture on unit cell, specifically HCP unit cell, hexagonal closed pack unit cell. Which cell is called as the HCP unit cell? So, according to the lattice parameter, if the unit cell consists A is equal to B but not equal to C factor, means the two edges of any unit cells are equal but third one is not equal, and alpha is equal to beta is equal to 90 degree but gamma is equal to 120 degree. Means the angle between A and B and C is equal to 90 degree, but C and A is equal to 120 degree. So, such type of unit cell is called as HCP unit cell. So, let us draw the diagram of HCP unit cell and then we will see the parameters for it. HCP unit cell So, this is the diagrammatical representation of HCP unit cell. See, in HCP unit cell there are 12 corner atoms 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. There are 12 corner atoms, 2 face center atoms 1 and 2 and 3 inside the body atoms. These 3 inside the body atoms squeezed by the 7 upper plane atoms and 7 lower plane atoms, means we can say in a simple language these 3 atoms is sandwiched in between the 6 plus 1 above atoms and 6 plus 1 below atoms. Due to that they forms the most compact structure, and in a real ground the HCP structure is a most compact structure. The good example of HCP structure are aluminum, gold, silver, these are the good examples. So, most compactness means it has a most efficient, it has most packing. So, that is why HCP unit cell is a very important unit cell. So, let us find the different parameters for HCP unit cell. Everybody is known that 7 parameters are required to describing any type of unit cell, but basically 6 parameters are very important. 7th one is again required, but number of times 7th one is not countable. First parameter is effective number of atoms per unit cell. As per our previous discussion in a crystallography chapter, at the starting of crystallography chapter, we discussed the basic 6 parameters for describing any unit cell, and in that there was first parameter is effective number of atoms. We had already derived the relation for it, and that relation is N is equal to Nc upon 2 plus Nc upon 8 plus Nb upon 1 plus Nf upon 2 plus Nm upon 4. But the given unit cell is a HCP unit cell. So, we can't apply here Nc by 8 because Nc by 8 is applicable for a cubic cell. So, we must modify this equation first and then calculate the value of N. Nc represent the corner atoms and in cubic cell each corner atoms divide into the 8 parts, but in hexagonal closed packed structure, HCP structure, each corner atoms divide into the 6 parts. So we can write here N is equal to NC by 6 plus NB as it is NB by 1 plus phase center atoms are there, body base phase center atoms, so NF by 2. There is no middle of edge atoms, so we can consider this final Nm by 4 is equal to 0 or not countable. Now we know that number of corner atoms, there are 8 corner atoms, so 12 by 6 plus body, inside the body atoms 1, 2 and 3. So 3 by 1 plus phase, here not a completely phase center atom, there are base center atoms. So we can write 1 and 2 base center atoms, so 2 by 2. Here 12 by 6 is equal to 2 plus 3 plus 2 by 2 1. So this is equal to 2 plus 3 plus 1 is equal to 6. So the effective number of atoms per unit cell in HCP type of crystal structures, it's 6. There are 6 atoms. These 6 atoms perform the important role to compact crystal structure, means HCP act as a compact crystal structure due to this 6. Second is a coordination number N. So according to the definition, we know that total number of nearest neighboring atoms in contact with any given atom is called as the coordination number. So for finding the coordination number for this given atom, we can directly count how many numbers of atoms in contact with this. 1, 2, 3, 4, 5, 6. So 6 atom in a plane, they are already contact with this base center atom. See, just below this plane there are 3 atoms. These 3 atoms, as per our previous statement, we know that these 3 atoms squeezed by the above 7 atoms and lower 7 atoms. Means indirectly we are considering these are in contact with this given atom. So this 6 plus 3, similarly 3 atoms will be available on upper side also. So 6 plus 3 plus 3, so there is 12. So coordination number of this given atom is 12. Now next factor is relation between A and R. So third parameter is relation between A and R. A is edge distance and R is radius of atoms. As per our previous discussion, we know that A is equal to B but not equal to C. Means all these sides are A or B, but the vertical sides are C. So we can write here A and R relation only for A and B but not for C, because they are not equal. So A and B, in terms of A and B equation of R, like this way, we can consider this to this distance directly, and this to this is A, atom distance is A. So A is equal to half of this atom means R plus R, 2R. This is equal to 2R, means finally R is equal to A by 2 or A is equal to 2 by R. This is the relation for A and R, but this is applicable only for A or B, not for C, because C having the different value as compared with the A and B. Third parameter is, that is the most important parameter, which is packing fraction. Here is atomic packing fraction because the structure is atomic. As per our previous discussion, we know that mathematical equation and definition of APF is equal to 4 by 3 pi r cube into N, volume of number of atoms per unit cell, to the volume of unit cell. Unit cell is here HCP unit cell. We can't here use A cube. See, 4 by 3 pi r cube into N. N, as per our discussion, number of atoms per unit cell, that is 6. So 4 by 3 pi r cube into 6 upon volume of HCP unit cell. So here A is equal to B but not equal to C. So we can't use A cube for calculating the value of volume of HCP unit cell. So our first task to find the volume of HCP unit cell for calculating the value of atomic packing fraction. So let us find the volume of HCP unit cell. So volume of HCP is equal to, as per the geometry we know that volume of HCP is equal to area of the base of HCP into height. So area of base of HCP into height. Height is from this to this is C. So we can write here height C. So for the next derivation we can use this part. So I will wipe this. See, volume of HCP is equal to area into area of base of HCP, area of base of HCP into height. Base. So from the diagram we can draw the base of HCP like this way. We can join corner to corner lines this way. So the complete base divides into 6 triangles. So let us consider this is the origin or O point, A point, B point, C, D, E, F. So these are the corners of base of hexagon. So O is the intersection points of all these lines. Due to that there are 6 triangles. First is AOB, second is BOC, third is COD, fourth is DOE and EOF. Observe this diagram, all sides are equal. As per our previous discussion we know that C except C, all sides are equal, means A is equal to B. So this and these sides are equal. Now here is the base center atom, here is the atom. So these two atoms are in contact with each other, and from the relation of A and R we know that A is equal to 2R, hence this to this is also A, because R plus R 2R is equal to A. Similarly this is equal to A, means the value of each side is equal to A. So from this diagram we can conclude the triangle AOB is congruent triangle. AOB is congruent triangle. If AOB is congruent triangle means all other triangle is also congruent triangle, equilateral triangle. So if they are equilateral means this angle is 60 degree, 60 degree, 60 degree. Means complete base divide into 6 equilateral triangles. So we can write here area of base is equal to 6 into 6 triangles are there. If we know they all are same type of triangle, means if we know the area of first triangle then we can find the area of second, third, fourth, fifth, sixth, because that area is also equal. Hence we can write 6 into the area of this triangle, area of triangle AOB. Now we know that area of triangle is half into height into base. Let us draw the normal over the AB, and that normal is OM. OM is normal over the AB. Hence we can write here half into base into height. From the diagram 6 into this half, base is AB, which is A, value is AB, height is H. We don't know the height, but we know that this side is A, this side is A, and we want H. So by using trigonometry we can use sin 60 is equal to front side upon hypotenuse. So this is equal to 6 into half into A into H. H is OA, OM is equal to A into sine 60, A into sine 60, and sine 60 is root 3 by 2. So this equation is 6 into half into A square into root 3 by 2. Let's see 2, 3. So this equation becomes 3 into root 3 by 2. 6 divided by 2. So there is a 3. So 3 and this root 3 upon 2 into A square. This is the value of area of base. Means this equation, volume of HCP is equal to, we can write 3 root 3 by 2 into A square into C, height of the HCP. Now our next task to find the height of the HCP. Next task to find the value of height of HCP, that is C. So from the diagram we know that there are 3 inside the body atoms and they are squeezed by the above 6 atoms, 6 plus 1 atom and lower 6 plus 1 atoms. So let us consider 2 corner atoms and 1 base center atom. Means this third one atoms which is inside the body of HCP present in between 2 corner atoms and 1 base center atom, and the position of that is orthocenter. What does mean by orthocenter? If we join these 2 atoms A and B, A and B, A and B are the corner atoms and C is the base center atom. Now if we draw the normal from this to this, which is CM or CN, normal from this to this, which is CD, normal from this to this, which is CQ or BQ. See here these 3 lines are intersecting to each other at this point. This point is a O point and this O point is called as a orthocenter point. The inside the body center atoms present in between 2 corner atoms and 1 base center atom, and the position of that is orthocenter. So we can consider this is the orthocenter position of that atom. So this atom is extra atom. Now the distance from this to this, if this is, I am considering Z, so O to Z is the half of the distance of total height, and total height is C, therefore this is C by 2, and our task to find the value of C. We can join here to here, this is 90 degree normal, from this to this C to Z is also A, because they are in contact with each other, and therefore R plus R is equal to 2R, means center of this C to center of Z is distance is nothing but the A. See the diagram. Now this diagram we want the value of C. So the given diagram shows us the right angle triangle COZ. So if there is COZ, means we can apply the Pythagoras theorem directly, and we know that Pythagoras theorem is CZ square, which is hypotenuse square, is equal to one side square plus another side square. One side is CO square plus from this to this OZ square. From the diagram we know that CZ is A, therefore A square is equal to CO square plus OZ is C by 2, means C square by 4. Again there is a one problem, we don't know the value of CO. So first we must calculate the value of CO and then we will put that value in this equation. CO from the diagram, CO is the distance of CN, and if this is the minor axis or it is the distance from orthocenter to the origin of one atom, then according to the geometry this distance is equal to 2/3 of total distance. Total distance is Cn. So here total distance is Cn. See, Cn is normal on AB also. Cn is normal on AB. Total distance AB is A A to B is again A because corner atom is also distance A. CB is also A because this to this distance is A. Now if this is the normal on AB, means there is again Pythagoras theorem. By using Pythagoras theorem we can write CB square is equal to Cn square plus Nb square. So Cn square, we want the Cn, therefore take the Pythagoras theorem property here and we can write CB square is equal to Cn square plus Nb square, Cn square plus Nb square. From the diagram CB, C to B is A, so A square is equal to Cn is this to this distance, from this to this distance, we want that distance, so as it is Cn square plus Nb square. Nb is half of the AB is A, so Nb is A by 2, so A square by 4. Therefore Cn square is equal to this on this side, so A square by 4 or A square minus A square by 4. This is equal to 4 into A, 4A square minus A square by 4. So this is equal to 3A square by 4, and finally Cn is equal to root 3 by 2. Square root of 4 is 2, so 3A. So Cn is equal to 3A. Put this value in this equation, then this equation becomes 2 by 3 into Cn is root 3 by 2 into A. So 2 to get cancelled, this is equal to root 3 by 3A. So this is the value of CO. Now put this value in this equation, then this equation becomes A square is equal to CO. CO is root 3 by 3 means 3 by 9 plus C square by 4. Okay, now this 1 by 3. So C square, A square, one term is remaining, A square there. CO square is 3 upon 9 A square plus C square by 4. So 3 by 9 means 1, 3. So A square minus this A square by 3 is equal to C square by 4. Therefore this 3 into A, 3A square minus A square is 2A square divided by 3 is equal to C square by 4. Therefore 4 on this side 8, so C square is equal to 8 A square by 3. Therefore now removing the square on both sides, C is equal to root 8 by 3 into A. So finally we got the value of C because we want the value of C. So this is the value of C. C is equal to root 8 by 3 into A. Put this value in this equation. So this equation becomes 3 root 3 upon 2 into A square into C. The value of C is root 8 by 3 into A. We can write here root 8 by root 3 into A. Root 3 get cancelled. So finally 3 root 8 by 2 into A cube. And this is the value of volume of HCP. This is the value of volume of HCP. Now put this value of volume of HCP in our previous equation. This equation is the equation of APF. So the APF is equal to APF, atomic packing fraction, is equal to 4 by 3 pi r cube into 6 divided by this 3 root 8 by 2 into A cube. By calculating this value, we can get the value is 0.73. So atomic packing fraction for HCP is 0.73. Now The voids, next parameter is voids. Voids is equal to 100 or 1 minus 0.73. This is equal to 0.3, 10, 7, 0.7 and 27. So voids is 0.27. So at this way, in this way we calculate the different values, different characteristics parameter for HCP unit cell. So this is the again very important point. Thank you all of you.